Matlab language. And here I want to give several topics on loops, conditional control, switches, and the very new one, the trial and error structure, which is I think it is Matlab's special command. So we can explain loops, conditional or if clause, or switch, or trial structure. So let's consider the loop control. Before I talk about that, let's consider a simple example. If we want to make summation to 1, 2, and up to 100, then what we need to do is a loop for computers. The computers do not know Gaussian formula, so they have to use from the very basis. So what we need to do is to just to go back to this one slide. Let's consider the structure of for loop. The for loop is slightly different from the one in C language, where V is a vector that can turn different things. I is each time the variable I extract one number from V, and the loop is executed once, and then go back to the point. I extract the second number in V, and then close the loop. And the loop will go on and on until all the elements in V are extracted. So this is the loop structure. If I write this one in C programming language, you may find it familiar. For instance, we can have I equals to 0, I is smaller than n minus 1, and I plus plus. Just something like this in C. And in Matlab, we have I equals to 1 up to n. And this is a vector. It is not necessarily in increasing order or in decreasing order. It can be of any combination. 1, 2, 3, 2, any combination. So there are certain advantages of using Matlab structure rather than the C structure. Normally, C structure are in extending or descending way. On this one, the V vector here can be composed of any order. So in this case, we can use the for loop to solve certain problems. For example, let's go back to the case again. We can assume that as accumulation variable, we can assume it to 0 first, and then we execute I from 1 to 100. Each time we take the value from the vector and edit it, and finally if we executed all the elements in the vector, then we add up from 1 to 100. So in this case, we can use the loop structure to perform I1 equals S1 plus I. We can use the command to calculate the result, but be careful that do not neglect the semicolon there. Otherwise, the intermediate result will be displayed. It will be quite annoying. So here we can display the result, and you know that is the correct result. No problem with that. So this is one way to do loop structures. So let's consider another structure, which is called while structure. The while structure will test the condition. If condition holds, then the loop will be executed once and go back to this point and test the condition again. Until the condition is not satisfied, then the loop will be terminated. So what what's the difference between the two structures? Still, let's consider the same problem. If we are trying to implement this problem with the vowel structure, it is a little bit complicated. First, we have to assign S2, which is equivalent to S1 to 0. Then I equals to 1, which is the first element in the summation part. And we test whether I is smaller than 100 or not. If it is not, then we can add it into S2 and add I by 1, and then we can continue to loop until this condition is not satisfied, which means I is larger than 100, which is not needed to be added to the sum. So use the same structure, we can obtain the sum as well. So we can get the same result. I'm not demonstrating any longer. So compare the two ways of performing loop structure. We can see that this one is much simpler than the other one. And I used this example to show the loop structure in Matlab. In fact, if you are using Matlab, where it's the simplest sequence, we can form a vector 1 up to 100 and use the sum function to add them up. So it is the simplest form. In this case, loop is not needed by the user. It is hidden somewhere in the program. It is not seen by the user. So we can solve the same problem by two methods, or by three methods. And we can see that the fourth structure is much simpler than the other one. So the question is, why we need a vowel statement? Let's consider another example. Suppose we want to find the summation of I up to certain terms. We want to see what is the value of m which makes this inequality whole. We can find the m. Of course, m is not unique. We need the smallest m which makes it inequality whole. For this problem, it is immediately seen that the for loop is not working because we cannot define the vector v because we do not know the last value of m. So in this case, the for loop is not useful. So we have to use the while loop. We have to define that s is 0 and m is 0. And then we can use this condition to check whether s, the sum is smaller than 10,000. If it is not, then we can execute this statement and add the n to n, and then go back to the loop again until the sum is larger than 1,000. Then the loop will be stopped. So in this case, we can find the value of s and n. So this kind of problem cannot be solved by the for loop. We have to use the while loop. So there are differences. For different purposes, we may use different loop structures. So let's check whether it is correct or not. So we can see that the result is correct. This is the loop structure.